Your assistant gave a great answer in the demo. Does that mean it works? Not even close. Change one prompt, swap one model, tweak the retriever, and you might silently break a dozen things you'll never notice by eyeballing one lucky example. This episode is about the discipline that separates a toy from a product: evaluation. We'll build a golden set, score it with cheap deterministic metrics and an LLM judge, and freeze the whole thing into a test that blocks regressions in CI. In episode 12 we gave Atlas memory. Today we ask the harder question: is it correct? LLM systems are non-deterministic and tightly coupled. A change that fixes one case can break 3 others, and you won't see it by hand. Professional teams treat answer quality the way they treat code, with automated tests that produce a number, run on every change, and fail loudly when quality drops. Let's build that for Atlas. There's a mindset that changes how you build with LLMs: eval-driven development. Before you write the feature or fix the bug, you write the eval case that defines success. Now done isn't a feeling or one lucky screenshot. It's a number that has to go up. From then on, every change you make to a prompt, a model, or the retriever is graded automatically against that bar. It's test-driven development, adapted for systems whose output you can't predict line by line. Build the ruler first, then build the thing. Every eval starts with the single most valuable artifact you'll build: a golden set. It's a small, hand-curated list of questions paired with what a good answer must look like: your unit tests for behavior. Here's the whole cycle. Take the golden set, run the entire app over it, score each answer with metrics and a judge, then gate. In CI, a score below your floor fails the build and blocks the change. The loop runs on every commit, and you grow the golden set every time a real bug slips through. That feedback loop is what steadily drives quality up instead of letting it drift. Each case records 4 things: the question, the chunk that actually contains the answer, the keywords a correct answer must mention, and whether this is an off-corpus question Atlas should refuse. That last category matters enormously. A support bot that confidently invents an answer is worse than one that says "I don't know." We include deliberate out-of-scope questions to test exactly that humility. A golden set of a dozen cases you maintain by hand beats 1,000 auto-generated ones nobody looks at. Cover the real spread: easy lookups, tricky multifact questions, ambiguous phrasing, and out-of-scope traps. And treat it as living. Every time a bug reaches production, you add the case that would have caught it. Over time, the golden set becomes the distilled memory of everything your product is supposed to get right. With a golden set in hand, score it into layers. The first layer is everything you can measure with plain Python: no model, no cost, no flakiness. Compute these first and run them on every commit. Think of evaluation as 2 layers. The cheap layer is deterministic metrics: did retrieval fetch the right chunk, and does the answer contain the required facts? They cost nothing and never flake. The expensive layer is the LLM judge, which catches the subtler problems code can't see. The discipline is simple: compute everything free first, and spend judge tokens only on what's left. To cheap, powerful signals. Context hit rate asks whether retrieval even surfaced the chunk that holds the answer. If it didn't, no model can save you, and you've localized the bug to retrieval. Keyword recall checks the final answer for the facts it must contain. Neither needs a model. Together they catch a huge fraction of regressions in milliseconds, which is exactly what you want running on every single commit. Refusal is a metric in its own right. For an off-corpus question, the correct behavior is to decline. For a grounded one, declining is a failure. Note the careful definition. A refusal is when the answer is the refusal line, not merely contains the phrase, otherwise a real answer that happens to quote it would be misread. Getting these definitions exactly right is half the work of trustworthy evaluation. Run the metrics on a sample and they return instantly, with no model call and no cost. This is the layer you can afford to run thousands of times a day. But notice what they can't tell you. Keyword recall confirms a phrase is present. It cannot tell you the answer is actually faithful to the source or genuinely addresses the question. For that, we need to bring in a model. Deterministic metrics are necessary but not sufficient. An answer can contain every required keyword and still be wrong. It could bury the fact in a contradiction, or technically mention it while missing what the user actually asked. Code can't judge nuance like faithfulness and relevance. So we add a second layer that can. We ask a language model to grade our language model's output. Using a model to evaluate a model sounds circular, but done carefully it's remarkably effective, and it's how serious teams measure quality at scale. The trick is a narrow rubric and strict, parsable output. The judge gets three things: the question, the retrieved context, and the answer. It scores to narrow axis, faithfulness, meaning every claim is supported by the context, and relevancy, meaning it actually addresses the question, each from 1 to 5, with a short reason. Crucially, a correct I don't know when the context lacks the answer is faithful, scoring high. Narrow rubric, integer scores, always log the reason. Here's the whole judge prompt. The art is in the constraints, to specific access, not a vague rate this, an integer 1 to 5 scale, not loose prose, an explicit rule for the refusal case, and a demand for strict JSON plus a one-sentence reason. The narrower the rubric, the more consistent the judge. And the mandatory reason is non-negotiable. It's what lets a human audit a surprising score in seconds. We send the rubric, question, context, and answer to the model here through the authenticated Cloth CLI, so it runs with no API key and parse the JSON into a typed verdict. In production you'd use the messages API with tooluse to guarantee the JSON, exactly as we did for structured outputs in episode 3. The judge runs at temperature 0 for repeatability, because an evaluation that changes every run is no evaluation at all. Here's a real verdict on a good refund answer: 5 for faithfulness, 5 for relevancy, and a reason that names exactly which facts were supported. That reason is the gold. When a score is low, you don't guess, you read why, and it usually points straight at the bug, whether it's a hallucination, a retrieval miss, or an off-topic ramble. Now let's put metrics and judge together into one harness. The harness runs at LAS over the whole golden set, scores every case with both layers, aggregates into a scorecard, and flags anything below threshold. Then we freeze it into a test so a bad change can't merge. One real-world wrinkle worth showing. Models sometimes think out loud, leading with a wrong refusal, then correcting themselves. That mess pollutes both your metrics and your users' screens. A small output hygiene step strips the meta-commentary and keeps the substantive answer. This is the kind of unglamorous cleanup that separates a smooth product from a janky one, and it's a perfect example of engineering around the model's quirks rather than wishing them away. The harness loops over the golden set, computing the cheap metrics and the judge verdict for each case, then applies a gate. If faithfulness drops below 4, or a refusal case was answered when it should have declined, that case fails. Answers are cached so a rerun doesn't pay for generation twice. The output is a single scorecard, the number you watch on every change. And here's the real result over all 12 cases. Faithfulness is a perfect 5 when Atlas answers, it stays grounded. But the harness caught one genuine failure, the SSO question, where Atlas wrongly refused a question the documents actually answer. That single red line is the entire point of this episode. We didn't find it by luck, the Evals surfaced it automatically. That's a real bug to go fix, and a new permanent guardian in our golden set. A scorecard is only useful if you can read it. Faithfulness at 5 says that when Atlas commits to an answer, it stays grounded. Excellent. Refusal at 0.92 pinpoints the one SSO case that wrongly declined. And context precision at 0.28 is quietly telling us retrieval is noisy, we're stuffing too many irrelevant chunks into each prompt, which we'd fix with the re-ranking from episode 8. Notice how each weak number points at a different layer to fix. That's the power of measuring the pieces, not just the final answer. One caution before you trust the judge too much. LLM judges have known biases, they tend to reward longer answers, confident tone, and a familiar style, regardless of correctness. So calibrate, periodically check a sample of judge scores against your own human judgment and adjust the rubric when they disagree. Be careful using a model to grade its own family, since it can flatter its own outputs. The judge is a powerful, scalable signal, but it's a signal, not gospel. Keep a human in the loop on the cases that matter. Finally, freeze the eval into PyTest. The deterministic tests are fast and model-free, perfect for running on every commit. The aggregate quality gate consumes the harness report and fails the build if faithfulness regresses or any case breaks. Wire this into CI and a pull request that degrades quality simply can't merge. That's the whole game, your evaluation becomes a wall that bad changes bounce off. The fast, deterministic tests pass in 0.03 of a second, cheap enough to run on every keystroke if you want it. The full quality gate runs in your slower pipeline before release, where spending judge tokens is worth it. 2 speeds, 2 stages, instant checks on every commit, the deep evaluation before you ship. That's how you keep quality high without slowing the team down. We built the judge by hand so it's never magic, but in production you'd usually reach for a maintained library so you don't own the prompts and parsing. Ragas is the standard one for RAG, it computes faithfulness, answer relevancy, and context precision over a dataset with one evaluate call. It's the exact 3 ideas we just built: a dataset, a set of metrics, and an aggregate score with the sharp edges handled for you. Understand the hand-rolled version, then graduate to the library. 2 more words to leave you with: offline and online. Everything we built is the offline gate, it runs in CI and stops regressions before they ship. But real users will ask things your golden set never imagined. So in production you also evaluate online, sample a slice of live traffic and run the same judge over it continuously. When you find a surprising failure in the wild, you harvest it straight back into the golden set, where it becomes a permanent test. Offline catches what you anticipated, online finds what you didn't, together they make the system relentlessly better. Recap. The golden set is the artifact everything hangs on. Score it into layers, cheap deterministic metrics first, then an LLM judge with a tight rubric and a logged reason. Freeze the whole thing into CI, and quality stops being a vibe and becomes a gate. Our own harness just caught a real bug where Atlas refused a question it could answer. Next episode, we harden Atlas against the messy real-world guardrails, prompt injection, and PII. See you there.